Dear friends, today I will be discussing a problem. This is to give some insight into problem solving. In our life, we face several situations which involves problem solving. Coming to physics, learning physics involves learning to solve problems. Problem solving being a skill, it can be developed by practice. For solving a problem in physics, we need to understand the situation involved and the necessary theory related to that. When we come to problem solving, the great work of George Polya is very important. He has written a book about problem solving. The title of the book is How to Solve It. In this book, he clearly demarcates the strategies to be adopted for problem solving, the steps to be followed in problem solving. I have taken into account his methods, his strategies, whenever I try to solve a problem. Here, I am solving a geometrical problem which involves the minimum of knowledge about physics or mathematics, but it involves the application of calculus. The problem I will state, it is like this. There is in a flat area, 4 villages are located at the 4 corners of a square field. At the center of the square field is located a well. The problem is to construct roads to this well so that the total length of the road so constructed is a minimum. I will make the statement once again. It is like this. There is a flat area in which 4 villages are located at the 4 corners of a square. At the center of the square is located a well. We have to construct roads to this well from the villages so that the total length of the roads so constructed is a minimum. In order to solve this problem, as suggested by Polya, it is good to draw a diagram. At the center we have the well, and at the corners of the square are the villages V1, V2, V3 and V4. Then, as it is not given that the side length is not given, it is arbitrary. So we can choose it as either A or 2A, which makes the analysis simpler, whether it is A or 2A. One direct way to solve is find the distances, is drawing lines from the villages to the well. For finding this distance, it is easier if we choose the side length as 2A. Side length is chosen as 2A. This distance becomes A. So that the distance from the villages to the well will become L1 is equal to 4 times square root of 2A square. This is equal to 4 times root 2A. Is equal to 4 times 1.414 A. This is equal to L1 is equal to 5.656A. If you look at this problem, we find that what are the possibility exists? Because the distance from a village to the pond which is located at the center, this distance is a minimum along a straight line joining these two places. That is what we have calculated. What the method is there? What is not given in the problem is any constraints. There is no constraint. So we can construct roads such that part of the road is shared by two villages. And one such case we will address first before coming to setting up a general problem to be solved. Suppose from V1 it goes like this way you can construct roads. What about the distances involved? And in that case, L2 is equal to this is A, this is A, this is A. 3A, two such things. That is 2 times 3A, 6A. L2 is equal to 6A. Clearly, L2 is greater than L1. Therefore, that will not help. That will not reduce the distances or the lengths involved. And what about another possibility? In the first case, there is minimum sharing. There is no sharing. In the second case, there is a maximum share. And what about looking for an intermediate case? Let this distance be x. L3. The partial sharing. Only this much distance is shared between the two villages. We can calculate the distances here. This is square root of. This distance is a minus x. This is a. This being x, this is a minus x. A minus x square plus a square. This is a. In this right angle triangle, this distance is this much. This, how many such distances are involved? 1, 2, 3, 4. 4. And x is 2 plus 2x. That is L3 is equal to 4 square root of a minus x square plus a square plus 2x. What about the values of x? Possible values of x. X is equal to 0, one case, that is L1. X is equal to maximum, A, that is L2. Therefore, x can be between 0 and A. Now let us look for the minimum of this L3. L3 is a function of x. Its minimum happens when the derivative of L3 with respect to x becomes 0. dL3 by dx is equal to 4 half into 4 multiplied by half divided by square root of a minus x square plus a square into 2a minus x to minus 1 plus 2. This is equal to 0. 1, 2 and 2 cancels here. This becomes minus 4 a minus x divided by square root of a minus x square plus a square this becomes 2. 1, 2 gets cancelled throughout. This is plus 1 is equal to 0. Taking this to the other side, 1 is equal to 2a minus x divided by square root of a minus x square plus a square. Cross multiplying and squaring, we get a minus x square plus a square is equal to 4a minus x square. 1a minus x square is taken to the other side. 3a minus x square is equal to a square, or a minus x square is equal to a square by 3, or a minus x is equal to a minus x square is equal to a square by 3. Taking square root, we get, taking square root on both sides, a minus x is equal to a by 3. Why we have chosen the plus sign a by root 3? Why we have chosen the plus sign? If you choose the minus sign here, x will become greater than a. But that is not possible because x is between 0 and a. Therefore, x is equal to a into 1 minus 1 by root 3. X is equal to a into 1 minus 1 by root 3. We can make substitutions here. L3 minimum is equal to 4 times square root of a minus x square is a square by 3 plus a square plus 2x to a into 1 minus 1 by root 3. This is equal to 4a square by 3. Taking the square root, with 4 2a by root 3 plus 2a minus 2a by root 3. 4 times 2a by root 3 and 1 2a by root 3. We get this is 3 to 2a by root 3 plus 2a. 3 and 3 cancel. So root 3 2a. Root 3 2a plus 2a is equal to 2a 1 plus root 3. Root 3 is equal to 1.732. Therefore, root 3 plus 1 is equal to 2.732. Therefore, the distance L3 minimum is equal to 2 times 2.732 A is equal to 4 A. L3 minimum is equal to 5.464 A. Thus we find that L3 minimum is less than L1. L1 is 5.656 A. whereas L3 minimum is 5.4648. Therefore, you have to choose an x, that is a 1 minus 1 by root 3, so that the length of the rod to be constructed is a minimum. Thank you.